Hi there, and welcome to IGCSE Maths Tutors. In today's video, we're going to explain a question that tackles ratios and scales. The wording of the question says, Rob is making a scale model of the solar system on the school field. He wants the distance from the Sun to Jupiter to be 8 meters on his model. The real distance from the Sun to Jupiter is 7.8 times 10 to the power 8 kilometers. Find the scale of the model in the form of 1 to n, where n is in standard form. When we talk about the scale, we're simply talking about a ratio between the real distance and the model, but keep in mind that this ratio has to be always in the same units. So we will write this ratio in the following form: model to the real, and under the model we put the distance in kilometers. Note that in the question the distance in the model is given in meters, so we divide these 8 meters by 1000 and we put simply the real distance in kilometers, which is 7.8 times 10 to the power 8. Now we want to know for 1 kilometer how much does this represent in real life. Therefore we simply cross multiply by multiplying the two ends of the cross, which are known, and dividing by the number whose other pair is unknown. Therefore n will be equal to 7.8 times 10 to the power 8 divided by 8 times 10 to the power minus 3. As you know, dividing by 1000 here is equivalent to multiplying by 10 to the power minus 3. From the video that we have done tackling powers, when we divide the same base, which is in this case 10, we subtract the powers, and therefore it is going to be 10 to the power 8 minus 3, which gives us 10 to the power 11, and then we divide the 7.8 divided by 8. This gives us 0.975, and hence the answer is 0.975 times 10 to the power 11. Putting this in standard form means that we should only have one number, which is not a 0, before the decimal place. If we move the decimal one place to the right, this gives us 9.75 times 10 to the power of 10, and therefore the scale of the map becomes 1 to 9.75 times 10 to the power 10, and this is the correct answer. The second part of the question says the distance of a space probe from the Sun is 1.9 times 10 to the power 10 kilometers to two significant figures. What's the probe's maximum distance in meters from the Sun on the model? When we say the maximum distance, this means we would like to get the upper bound of 1.9 times 10 to the power 10. Now the upper bound for 1.9 is equal to 1.95, because as you know, the upper bound is the minimum number that would round up the number in question. In this case it's 1.9. So in order to round up 1.9 to become 2, the minimum number required is 1.95. If you're still unsure how to get the upper bound, you can consult the video whose link appears on the screen now to review this. So if the scale on the map says that for 1 kilometer on the model represents 9.75 times 10 to the power 10 kilometers in real life, which is the answer that we got to the first part of the question. Therefore, how many kilometers on the model would be represented by 1.95 times 10 to the power 10 kilometers in real life? Again, we cross multiply, and therefore the distance on the model would be equal to 1.95 times 10 to the power 10 divided by 9.75 times 10 to the power 10, and this gives us 0.975. 0.2 kilometers. Remember that we should get the answer in meters, and therefore we multiply 0.2 by 1000, and this gives us 200 meters, and this is the final answer. I hope you found this question easy and useful. If you like this video, please give it a thumbs up. If you still have questions, don't hesitate to put them in the comments section below. Meanwhile, I'll see you again in the next video. Goodbye for now.